Okay, welcome back to the SSAS training sessions. And in last session, we discussed about attribute relationships, right? We just created one hierarchy, and you have seen how to create hierarchies. And also, we discussed about attribute relationships. When I add these attributes, if you see, I created a hierarchy using 3 to 4 columns, right? In other words, 3 to 4 attributes. And you can see those 4 has come out. Those 4 attributes are not as part of the time key column, right? So if you don't have this hierarchy, let's say I deleted this hierarchy, then you can see all the attributes are part of the time key. That is, all the attributes, all the columns that are present in this particular table, which we use to create the dimension, is dependent on the primary key column. So for example, if you want to calculate calendar quarter, it will go to time key and it will join, get the information and group by, right? Let's say calendar quarter is your requirement. So how you will get the calendar quarter information? Select sum of sales amount from fact internet sales, limit as A, inner join, dim time, limit as B, on A dot order date key is equal to B dot time key. So if you observe, it is joining based on the time key. That is the root, that is the primary key column for this master table, and hence everything will be done based on the primary key column. Our requirement is group by calendar quarter, and the same should be present in the select statement. If you see, it will take the time key and it will join with the order date key, and it will get all the records from fact internet sales, and it will take the sum and then group by, and finally fetches the result. So the problem here is, every time for every attribute, for example, for calendar semester quarter, it will go get all the records from the fact table and then it will calculate. And calendar semester, again the same job, it will go calculate and get all the records and calculate. Calendar year, so let's assume I have 5 crore records in my transaction table, in my fact internet sales table. So to calculate this calendar quarter, it will go and get all the 5 crore records and it will process the group by statement. And for calculating calendar semester, it will do the same. It will get the 5 crore records from the fact internet sales table, and then it will calculate the group by statements based on calendar semester. Similarly for calendar year, similarly for date number of the month, similarly for date number of the week, day number of the year, English day name of the week, English month name. So everything for every attribute. Why? Because all these attributes are dependent on the primary column, that is time key. It is directly dependent. There is no hierarchy defined. There is no attribute relationships defined. So attribute relationships, what it will tell is, what it will tell to the server is, man, if you follow the attribute relationship, whatever you have given here, the performance will be improved. Let's see how it will be improved and how the relationships will be given. Let's say, to do the same, first I have to define if there is any hierarchical data. Hierarchical in the data in the sense, you know about hierarchies, right? Hierarchical data in the sense, this and this one has children, and this one has children again. So this data is called hierarchy. Family hierarchy, family tree, we will call it as, right? In the same way, you will have hierarchies like this, and this one will have children. So this data is called hierarchical data. The data is hierarchical in nature. This is the first level, this is the second level, and this is the third level, and this is the fourth level. So like that you will be getting n number of levels, depends on the hierarchy size. Now let me define one hierarchy. You know the default hierarchy. If you ask what is the example for a hierarchical data, then blindly people will say year, quarter, year, semester, quarter, month. So year will split into semesters, and semesters will split into quarters, and quarters will split into months. Or in reverse case, if you say months will roll up means sum up, roll up and give you quarters, quarters will roll up and give you semesters, and semesters will roll up and give you years. Now this kind of data is called hierarchical data. Let me create one hierarchy. Calendar year, calendar semester is the next level, and calendar quarter is the next level, and finally English month name. So I have four levels in my hierarchy. The first one is year, second one is semester, third one is quarter, and fourth one is English month name. And you can see now it came out and it is asking you to define a proper hierarchy. You said there is a hierarchy and you defined a hierarchy here. Now set the relationship between each level. There are four levels, right? Set the relationship so that analysis server will follow that relationship. Let me show you how to do that. Now you know very well that each and every attribute that is present in this list will go to the time key to calculate any fact data. Like it will join and to get the to calculate the fact level data, like sales of sum of sales amount or sum of tax amount or sum of freight amount or something else. But these four I defined a hierarchy. That means I said this data is hierarchical in nature. That means one attribute data is dependent on the other, right? That what it means. Now it's our job to tell how these are related, how the attributes are related. I will show you how to do that. Then you can try for the financial year or physical year. You know the least one is English month name, right? And you also know English month name. If I give 12 months data, you can easily calculate calendar quarter. And if I give quarters, you can calculate semesters. And if I give semesters, you can calculate years. Now let me take an example here. Let me take Excel. Let's say I have 5 crore records and our data is like this. Jan 1st, the amount is $100. Okay, this is better. So I've gone like this till May 16 of some year. Let's say $100. Let me make it as an increment one, and I'll make it as $200 here. So this is how data. This is how you have data in your fact table and the dimension table. When you join two tables, it is coming like this. Let's assume. Okay. Now to calculate month-wise data, what you will do? You will join, and for example, January data, you will go get all these values and paste it in the separate one. Like 4,600 is the January value. Jan, it's 4,600, right? In the same way, you will do for Feb. Let's say this is your fact data and this is your dimension data. You join two tables and the output is this one. I'm giving you just a dummy output. Okay, better. I'll give you a original output, good output. Okay. Let's say I'm grouping it based on time key, full alternate key, order by full alternate key. Okay, this looks better, right? Let's say I'm copying all the data into the Excel. Okay, I copied it. It is not taking the time column properly. Let me format the cells. This is time and date. Okay, now this is date of sales and this is sales, correct? Now if I give you this information and if you see there are something around 1125 records. Okay. Now if I give you this information and if I ask you to calculate what is the monthly sales, what is the monthly sales, then what you will do? You will go through each and every record and you will get Jan data and you will put some value, right? Feb data and put some value. March and some value. April, some value. May, June, July, August, September, October, November and December. Let's say I'm having some values for each and everything. This is based on the calculation. Let's assume this is purely based on this calculation. Okay. Now I can calculate that, Vikram, but let's go with this example. Now, how you got this value? You will get this value only when you go row by row and calculate it, right? Based on the primary key column, join with the fact table, group by, just like how you are grouping by here. Let's say if you group by English month name, you will get the month-wise sales, correct? The same way I got the sales. Let's say I have this in my hand. I have this information in my hand. Now, if I ask you, what is, give me quarter-wise sales, what you will do? So what you will do is you will just take the first 3 months and you will add this value. Okay, and you will say this is quarter 1. And these 3 months you will give quarter 2. And these 3 months this is quarter 3. And these 3 months this is quarter 4. So how many records you are depending on to get the quarter value? To get quarter level value, you are just depending on 12 records. All the quarters I'm saying, you are just depending on 12 quarters. Let's say you have quarter 1, quarter 2, quarter 3 and quarter 4. And you got the value, you got the values like this. Let's assume this is junk value. Okay, you are getting these values. Now the requirement is how to get the semester values here. So to get the semester 1 value and semester 2 value, you will just go and get from the quarters, either from quarters or from months. If you sum the first 6 months, you will get first semester. In the same way, if you sum the first 2 quarters, you will get first semester, right? So you are going to depend on either these records or the other one, either monthly records or quarterly records to get the semester records. Now to get the year value, you will just add these two, right? So this is how, see, the first level, the month level, the least level I can say. The least level in the hierarchy is, what is the least level in the hierarchy that I have defined? It is month. The least level will go each and every record and it will calculate the values. So the next level will be dependent on the least level, right? The third level will be dependent on the second least level. And finally, this will give you the year level information, right? The same way you have to specify. You have to specify the same thing in SSAS attribute relationships. Let me show you how to specify that. You know what is the least level here in this one. The least level is English month name, and English month name should be dependent on time key to get the data. Should be, right? This guy will roll up and give you quarter information. So select this and drop on this. And this guy will roll up and give you semester level information. So drop this. And this guy will give you year wise information. So drag and drop this. So this means if you see the arrow mark, the error mark is going like this. So first year level data, time level data, every day level data will be there if you use this time key. And using this time key data, that means this day level data, I will calculate month level data. And using this months, I will calculate quarters. And using these quarters, I will calculate semesters. And using these semesters, I will calculate years. Now, you can see the icon is gone, the warning message is gone just because you have defined the hierarchy attribute relationships. Now let me define one more hierarchy for physical year, physical semester, physical quarter, and the same English month name. There is common one, that is English month name. Now, if you see, English month name is common, and this guy will roll up and give you quarter, right? It's split up. Using this guy, I can get either quarter, physical quarter information or calendar quarter information. You know, right, the difference between physical quarter and the calendar quarter. I'll give you a brief about this after defining this hierarchy. This quarter will give you semester information. Physical semester will give you physical year information. Now you can see for two different hierarchies, I have defined the attribute relationship. See, this is how you have to define the attribute relationship. The least level should be the first one, and then it should be like a continuation roll up. And if you see the difference between physical quarter and the semester, calendar quarter, Jan, Feb, March, April, May, June, July, August, September, October, November and December. So these are all the months that I have. Calendar quarter is the one which is followed by the complete full planet, guys. So calendar quarter is, it starts at January and it ends at December. So the calendar quarter, this is the first quarter, right? This is the first quarter, this is this is also first quarter. The first three will be one quarter. Oops, it's copying. Quarter one, this is also quarter one. The second 3 months will be quarter two. This one will be quarter three. And this one will be quarter four. Right? So this is how the calendar quarter will follow. Now let's see. I'll name it as calendar quarter. I'll name it as physical quarter. Physical quarter will be varying from company to company, business to business. Let's say few banks will consider April to March. That means April to first 3 months will be quarter one. These three will be quarter two. These three will be quarter three. And next year, January, February, March will be quarter four. That is next year, right? And few banks or few companies, they will start their fiscal year. They'll start their fiscal year from July. Let's say this company started from July. So this one will become quarter one, quarter one, quarter one, quarter two, quarter two, quarter two. And next year, January will be quarter three, quarter three, quarter three, and April will be quarter four, quarter four, quarter four. So it depends on company. Company to company it will be varying. It's not a standard one. Okay. It all depends on how you are maintaining the business, how you are this physical quarter is mainly for the biggest companies, giant companies, where they will publish their results. Okay. How the quarterly sales was there and so on. Now, if you see, let's say calendar semester. The first four will be semester. The first 6 will be semester 1, right? These 6 will be semester 1, and this 6 will be semester 2 for calendar semester, right? But the case is different for physical semester. Why? Because the physical semester it starts from July. So this guy will become semester 1, and the next year January 2 so and so will become semester 2. So this is how the calendar quarters and the semesters will be quarters and semesters will be varying. But if you see, the months will remain the same. The months will remain the same. It's the same January to December. There is no change in the month. That is why the month they are maintaining only one in this particular example. If you want to maintain separately, you can maintain it. And let me show you the difference in the dim time table. Select calendar quarter, select star from dim time. Okay, this will give you complete dim time. Now what I'm gonna do here is distinct calendar quarter, comma, physical quarter, comma, calendar semester, comma, physical semester. Now if I execute this, if the calendar quarter is 2, the physical quarter is 4. That means it is starting from June. And calendar quarter is 3, that means it is the physical quarter is 1. So if you see, I will order it. That's better. Order by calendar quarter. So the calendar quarter started from Jan to March. Okay, 1. But here it starts from July to August, September. So just how I have shown the example. And you can see the semesters. The first 6 months is first semester, second 6 months is second semester. But here physical it's opposite. So this is how the calendar quarter and the physical quarter differs. And this is how you can give the attribute relationships. The advantage is if you have some millions of records in your fact table and only month level it will be calculated. That means only once it will go and calculate for the complete data. And for this attribute, these 6 attributes, it will be based on 12 records or how many records it is gonna fetch, right? If let's say it is fetching some 50 records, it will be calculated based on the 50 records. And you can give n number of levels. It's not, I have, in my first cube, I have used some 20 levels to define one hierarchy. If the data is hierarchical in nature, then you can go for n number of levels, but it always depends on your requirement. If your requirement says, I want to see year, quarter, semester and month, some guys will go for 15 days. Under this month, they will go for 15 days, after that weekly, after that daily, after that hourly. So they will go for so many hierarchies, so many levels in the hierarchy, and it all depends on how your end reports, how you are going to design your end reports. Performance point of view, it's not, as long as the data is hierarchical in nature, you can define n number of levels. Let's say English month name. After that, if you give 15 days, it's a performance advantage only. Why? Because the data is hierarchical in nature. Let's say you have one-to-one relationship, like employee ID, employee PAN card, employee, what is the other one? Employee passport, employee visa number. All these are one-to-one. One employee will have only one information, right? If you define a hierarchy based on that stuff, it will not make any sense. It's a performance hit. It's of no use. So as long as the data in hierarchical in nature, you can go ahead to n number of levels in the hierarchy. Now, if I process this, what will happen? I have to give the password. Let me process the dimension. I'm just processing the dimension. I'm not processing the complete cube. So as expected, the dimension processing fails. If you see, day number of the month, ID, some issue, calendar semester value 1 is repeated. So what is the problem here is, month wise I have to split into financial quarter and calendar quarter, right? So let's take any one, calendar quarter. I have to split into calendar quarter and I have to split into calendar semester. The problem here is, I'll get, if I execute a month wise query, okay, I'm taking month wise query here. Okay, this is the month wise query. And if I execute this, it is giving me month wise sales, right? The complete month wise sales. The same I will be getting here. If I execute at this level, I will be getting month wise sales. The problem here is, this is giving me complete aggregation, right? This April is for 2001, 2002, 2003, 2004. And August is for 2001, 2, 3, 4. And December is for 1, 2, 3, 4, 5, 6 and so on. So what quarter it has to take, which month it has to fall into which quarter. You understood? This calendar quarter will have, I'll write one more query. Select distinct star from dim time calendar quarter from, I'll get only 4 quarters. And first quarter I can take January, February, March, right? And second quarter I can take April, May, June. And third quarter I'll take July, August, September, and fourth quarter October, November, December. This is fine. Now let me write one more query. I'll take calendar semester, and here I'll take first 2 quarters for semester 1 and second 2 quarters for semester 2. And finally let me take calendar year. Okay, now got the problem. This is the problem. What is the cause for this? Let's say I have these 4 queries. Now if you take this, I have months. Okay, I'll take first January, February, March. Let's say Jan, March and Feb, and I'll place it into quarter 1. correct? And April, I'll take April. May, June, it will be somewhere in the bottom. I'll take April, May, June, and I'll place it into quarter 2. And I will add these 2 quarters to semester 1. Is it clear? Okay, better let me show you the complete data and then you'll get clear picture. Actually, this is not in order. Let me order it first. Order by month number. Month number of the year. I think this is the better one. Invalid order by. Okay. I have to make it in the group, I think. Control C. It will not make any sense if I add it here also. Okay. Now, I have information here. Let me order the second query based on quarters. And let me order by quarters and order by calendar year. And semester is already ordered. Now, let me show you an example. Let me show all the columns. Okay, November until December I have. Let me minimize this and let me minimize this so that everything will be visible. Now you can see everything here, right? Let me erase the drawings. As discussed, what will happen? The first, you have 3 months. Okay. These 3 months will get you the first quarter data. And second 3 months will give you second quarter data. And third 3 months will give you third quarter data. And last 3 months will give you fourth quarter data. Is it correct? Now, these first 2 semesters, these 2 quarters will give you first semester data. Correct? And second 2 quarters will give you second semester data. Will you agree? Now, if I add these 2, what will be the year information here? It will go and fall into which year? 2001 or 2 or 3 or 4? Which year information it is gonna get? You are gonna get based on calendar semester. Can you understand the problem here? What is the problem you are gonna face if you do this? The first level, it will roll up properly to second level. The second level will roll up properly. But the third level, if you see, it will not roll up properly. Why? Because you have more values. Right? Now, how can we overcome this? It is not giving me, see, I'm getting 12 months information. This 12 months information I can split into 4 quarters. This is fine. And this is fine. But this is creating problem. So what I can do here? How can I overcome this? The one way of overcoming this is adding year in every part. For example, if you add group by year, second, I'm adding calendar year in every group. Okay. If I add calendar year here, what will happen means it will split year wise month. This is 2002 January, 2003 January, 2004 January, right? You know how if you add year, how it will group by. It will group by calendar year and English month name, and hence it will split everything. Now, the semesters also should be split based on year, right? Calendar year, comma, semesters. So you will get semester for each quarter. And similarly, quarters, I'm sorry. The third one is semesters. Okay. Now let's see the same. I have added year in front of each and every group by statement. For every group, I have added year also. Now, if you see, it will take 2002 January, 2003 January, and 2002 February and 2002 March, and it will add it to 2002 first quarter. Similarly, 2003 Jan, 2003 Feb and 2003 March will be added to 2003 first quarter. And 2004 Jan, 2004 Feb, 2004 March will be added to 2004 first quarter. Similarly, the same will be repeated for the remaining quarters. Now, if you come to the semesters, 2001 semester 1 will be added based on the 2001 Jan, Feb, March. So, you are splitting every information, the least level information based on year, and adding to the next level information, that is quarters, which is split based on year, and quarters is providing information for the semesters, which is again split based on quarters, based on years, and finally it will be added to the semesters, years. So is it clear how we can overcome this just by adding an year? You are adding an year to group by, so that the data will be grouped with one extra column, that is year, so that the combinations will be increased and everything will go into the right bucket, right? Instead of January, here what you are getting, instead of January you are getting 2002 Jan, 2003 Jan and 2004 Jan. So 2002 Jan will go into 2002 first quarter, 2003 Jan will go into 2003 first quarter, and 2004 Jan will go into 2004 first quarter. In the same way, 2002 first quarter will go into 2002 first semester, where it is somewhere here, 2002 first semester. So just by adding 1 year, it is giving me proper bucketing. The problem here is the same. They have only 1 year. How I can manage it and how I can bucket it? So how to overcome this? What you can do to overcome this? Now let's go back to the dimension structure, and here I'm going to explain you about three important properties in real, that is key column and name column. While creating a dimension, you might have seen the key column and name column, right? Let me create one more dimension to show you the same. Every attribute will have 3 different columns. Let's say I'm taking the attribute dim time. You can see the key column is time key and the name column is also time key. So this is key column and this is name column. What is meant by this key column and what is meant by the name column? Let me demonstrate you an example here. I'm taking only time key, next, and click on finish. I don't have any other attribute. I have only one time key, and the key column and the name column is same, that is time key. So I have not changed anything. Okay, the key column and the name column is the same. Now let me browse and see what it is gonna show. If I select the time key, you can see only one attribute I have selected. It is showing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now let me go and change the property of this attribute. You can see 2 properties. One is key columns, which is set to time key, which I have selected while creating the dimension, and name column is none. Okay. If the name column is blank, that means it will take the key column. Whatever it is, the key column, the same will be taken here. Now from the name column, from time key or blank value, I am changing it to some other, let's say full date alternate key. Okay, the key column of this attribute is time key. The name column of this attribute is full date alternate key. Now let's see how it will query the data. Okay, I'm processing it. The dimension is processed. Let me go to the browser. Let me reconnect it. If I reconnect, you can see the display part is changed. Okay, the key column is used for querying purpose. This key column will be used for querying purpose, and this name column is used for display purpose. Okay, the querying will be done based on key column. The name column is used to display whatever you are going to display. Now let me show you one more example to demonstrate the same key column and name column. I'm taking calendar year. And if you see whatever the attribute I drag, by default the key column will be the same, the attribute I drag, and the name column will be blank by default. That means the same calendar year. If it is blank, it will take whatever it is there as part of the key column. Now it will go and get the distinct years that are available in the database, right? Every attribute will execute a distinct query. I'll show you the query also for your reference. If you see, this is the calendar year, right? You can see 5 rows have been read. And if you see the query, what query it has read, select distinct calendar year as so and so from dim timetable. You can see it here, right? So what it will do is every attribute it will go and get the distinct, and there it will have internally some joins and all, okay, some links. Now let me reconnect and let me select the calendar year. So if I select the calendar year, you can see 1, 2, 3, 4, and the fifth one is all, okay, blank or all will be there. If you see 2001, 2, 3, 4 you are getting. Why? Because the name column and the year column is same, right? That means it will go for select distinct calendar year from dim timetable. Now what I'm gonna do here is, for the same calendar year, let me change the key column. I'm not changing the name column. Name column will be the same. The key column, instead of calendar year, I'm taking time key. Okay. That means the querying will be done based on time key here for the calendar year. But whenever you drag and drop, it will show years. Okay. Let me show you the values now. I'm going to the browser. Let me reconnect it. You can see everything is showing 1, 2, 3, 4, 5. For everything it is showing years. Can you see the querying is changed completely now? No, it is showing only this. Now the querying has become key. Now what I'm going to do here is I'm going to change the name column to calendar year. That means the querying will be on time key, but the display will be on year. Let's see how it shows. So if you go to the browser and reconnect it now, you can see it is showing, even though it is querying based on key, it is showing years here, whatever the year value it is having in the database. So in short, it will be like this. Select a distinct time key, comma, so and so. So this will be your querying part and this will be your display part. Even though it is querying based on key, it will display here. So it all depends on the key column and the name column you specify. Here if you see the key column is this, then it will be querying based on time key. If the key column is name column is here, it will be displaying here. Now how this is gonna help us? How this is gonna help us in our hierarchies? So calendar year, it is fine, no problem. Calendar semester, we need to have one more group, that is calendar year, right? If you see the queries, whatever I've written here, it should be calendar year to calendar quarter, so that it will create one extra bucket, correct number of buckets to load the values that is being fetched from month name processing, right? So what I have to do, the key column, it should not be processed based on semester. That means it should not be based on group by semester. It should be based on group by calendar year and semester. So both. Now I have created a distinct one. So whenever you have a collection of key columns, then must and should give the name column. If you don't give the name column, it will get confused which value to be shown. You have two columns or more than two columns present in the key column value. So you have to specify the name column. What name you want to show? You want to show calendar semester. Now the third one is calendar quarter. So the calendar quarter, it is currently grouping based on calendar quarter, but it should be calendar year and calendar quarter, as I showed you in the last example. So let me add this and order it in the same fashion, calendar year and quarter. And now you have two columns added as part of the key column. That is why it is showing as collections, and hence you need to add some name column. So what I want to show when I drag this, I want to show calendar quarter. And month, if you see, it will be grouping based on English month name, which will be a problem again. You will get only 12 records instead of year wise. So let me add calendar year and order it. And what you want to show in the name column, the name column is English month name. It will be somewhere here. I can't see that. Okay, here it is. Now similarly for this hierarchy I have to do the same. So physical year, it is fine. This is high level. The next level is physical semester. The physical semester should be processed, should be grouped based on physical year and physical semester. So let me select the physical year and let me order it. So once I have added the key columns, I have to select the name column. Why? Because it should have some value when you have more than one key column selected. So let me select physical semester here. Now in the same way I have to do for physical quarter. So let me group it by fiscal year, which will be in the bottom, and fiscal quarter. The group by part is fine. Now the name column will be added to fiscal quarter. And month name is already we have added calendar year wise. So it will be grouped based on year wise. That will be fine for us. Now what I have done is I have created buckets for everything. I have created buckets for all the data. So now let me process it and let's see whether it throws any error. So it is not throwing any error. It is successful. Now you can see one major problem if you have like this is if you drag and drop month, the hierarchy will work fine. If you see, this is calendar hierarchy. It has a second semester data and third and quarter months data. Sorry, third and quarters data and each month's data. So this is the hierarchy you have created. Now you can see the hierarchy 1, that is for physical calendar. It starts from 2002, semester 1 and 2. This is quarter 1. This quarter 1 is nothing but quarter 3 of 2001 in calendar, normal calendar. Now if you go for a month, English month name, how many you will get normally? By writing a distinct, you will get 12. But here you can see 1, 2, 3, 4, 5, 6 something, some 36, 42 or something. Why? Because I am grouping it, I am querying it based on year and year and English month name. Back end it will be year and English month name, but front end it will show only month name. So it is nothing but you will get these many combinations. 2002 Jan, 2003 Jan, and so on. You can find Jan 3 times here. Jan here and here. This is the second one and this is the third one. So this is how you can define the hierarchies, and once you define the hierarchies, you have to go for attribute relationships. And once you define the attribute relationship, then you have to make sure that the data is properly setting into the buckets. Okay. This is mainly because of the property that is present between the relationship type. You can see flexible and rigid. There are two properties between each and every attribute, that is flexible and rigid. So rigid means it should not move from one place to another. Flexible means it can be moved from one place to another. The rigid example is, let's say calendar year and quarter. Can calendar year, January of 2003, is it possible to move it to year 2004? Will it make sense if I move the year 2003 Jan to year 2004? That is rigid one, fixed one. 2003 year will have only 4 quarters that belongs to 2003, and each quarter will have 3 months that belongs to 2003. Right? That is fixed. And if you see, Mumbai will be part of India. It cannot be moved to some other, right? So this is called rigid relationship between two attributes. So the values in this one, will be rigid to these quarters, and these quarters will be rigid to semesters. Semesters will be rigid to years. So this is fixed relationship. It will not be moved from one relationship to from one parent to another parent. In short, I can say This guy's parent is month, name parent is quarter, quarter's parent is semester, semester's parent is year. So that means a member cannot be moved from one parent to another parent. Example is calendars. This is perfect example. And if you want one more example, the cities. Generally it may happen, but 99% it won't happen. The cities will not move from one state to another state unless it is a city like Chennai, which is moved from Andhra long back, and Telangana. So apart from these kind of stuff, generally it is a fixed one. It's a rigid one, right? At least take geography locations. A particular geography location will not move. It will be rigid. It will be fixed. But the flexible one, the example for flexible one is rental car is an example. It will be moved from one guy to another. Today it's with me. Tomorrow it's with another guy, right? One rental car can be moved across so many users. In the same way, one employee, let's say myself, I am working under Krishna today. Tomorrow I will be working under for some other project and some other manager. So my manager is my parent in hierarchy, but I am not fixed one. I am rigid. Sorry, I am not rigid. I am flexible. I'll be moving from one manager to one manager, another manager, depends on the project that I am working on. So this is not a fixed relationship. That means this is not a rigid relationship. This is called flexible one. So these two kinds of relationships are very important to know in SSAS attribute relationships. Okay, this is about, we discussed about all the stuff that are required for creating the hierarchies, attributes, that are required for creating the cubes. So you are ready to, you have good enough knowledge to create a cube now. The basic cube, I can say, with the dimensions, with the measure groups and the relationships. We discussed about all the relationships. Let me save this file here, and we are not going to discuss anything related to dimensions now. Well, the dimensions are cubes now, but we are going to discuss about one important property which you will find in the dimensions. If you select the dimension, you can see storage mode. You have a molap and rolap. You have two storage modes in the dimension, right? Remember this very carefully. This is very, very important interview question. And without this, I don't see any interview, okay, on SSAS mainly. So for a dimension, you can set any one storage mode from this list, that is molap and rolap. By default, it will be set to molap. This is the first question I faced when I've given interview on SSAS. And I don't know what is this property and where to set it. He asked me what are the storage modes. No answer. Okay, what is the default storage mode? No answer. Because I have never seen this property before. So let me explain you this. This is very important one, and I face this in almost all the interviews. Storage mode, you have two options at the dimension level, that is molap and rolap. But if you go to the cube, let me select the cube. You will find the same storage modes in partitions. You have a partitions tab, right? You can see the storage settings. You can see three different options. One is molap, which you have seen in dimensions. Another one is rolap, which you have seen in dimensions. In the middle, you can see holap. Somewhere here, you can see folap. And all these intermediate ones, these are just related to molap. At high level, you have only three. One is molap, another one is holap, and another one is rolap. So how many storage modes you have? If you take the Excel again, you have three storage modes. One is molap, holap, and rolap. So what is meant by storage mode? Before going to each type, let's discuss what is storage mode. Why we need to discuss about this storage modes. What is meant by storage mode? What you can think of when I say storage mode? Just give me your views. What you can think of if I say storage mode. Okay, very close answers. As you all know, we fetches the data. When you click on process, what will happen? It will go fetch the data from your relational database. Let's say this is your relational database and this is your analysis server. And this is your cube project, SSAS project. When you click on process, what it will do? It will go here, get the data and create aggregations on the data, and it will create indexes on the data, aggregated data, and it has to store somewhere. It has to store the data somewhere. So this storage mode will talks about where the data will be stored when the cube is processed, right? It will be fetching some thousands and millions and millions and millions of records from your relational database whenever you process. So it will get that and it will create aggregations and it will create indexes on it, and then where it is going to store. So the storage mode talks about where the data will be stored once it is processed. And in that we have three options. One is MOLAP, another one is HOLAP, and another one is ROLAP. Now let's see what is MOLAP, HOLAP, and ROLAP. So the first one is MOLAP. The defaulted one is MOLAP. For any cube, for either cube or dimension, the defaulted one is MOLAP. This MOLAP, if you see, let's say this is your SQL server or any relational database. This is your project and this is your analysis server. So if you select the MOLAP, so it will go here, get the data, and it will copy the data here into your analysis services. And here in this, it will create aggregations and it will create indexes on top of the aggregations. So in short, you will have two things. One is data, the complete data, right? The data that is being pulled from analysis service, SQL server or any relational database. And the other one is aggregations, right? So the aggregations as well as data will be stored in analysis services if you select MOLAP. If you select ROLAP, the project will not do anything for the data. It will not read data. It will keep the data as is in your relational database and it will create aggregations here. It will create new tables and it will create aggregations and it will store the aggregated data in the same database. There is nothing called storage here in the analysis server side. The complete storage will be on a relational database where you are pointing to. And if you select the whole app, the third one, the relational database data will be here. That is, the data will be here and aggregations will be stored in analysis server side. So in short, MOLAP storage mode will store the data as well as aggregations on the analysis server, and ROLAP will store the data. It won't store, it will keep the data as is that is present in the relational database, and it will create aggregations in the same database. And if you select HOLAP, it will leave the data as is in the relational database and it will store the aggregations in the analysis server. So these are the three types of storage modes that are available, and by default it will be MOLAP, and 95 to 98% of the projects will go with MOLAP storage mode, and remaining percentage it will be ROLAP, and 0.0001% it will be HOLAP. And if you ask me to repeat HOLAP, it's like the storage mode. See, you will have data here, right, in your relational database, and the cube project will pull the data and copy it into your analysis server, and also aggregation, it creates aggregations, then that is called MOLAP. If you don't do anything to the data and if it instead of that it create aggregations in the same, then it is ROLAP. And if it don't do anything to the data and it creates aggregations only in analysis server, then it is HOLAP. Now let me tell you the definition for each, full form of each, so that you will get clear picture. MOLAP means multi-dimensional OLAP, online analytical processing. Multi-dimensional means it's nothing but analysis services. Everything will be in analysis services. ROLAP means relational OLAP, relational online analytical processing. That means the SQL server or whatever you are connecting to. HOLAP means hybrid. It is mixture of both. The data will be at the relational side and the aggregations will be on the multi-dimensional side. The next question will be, what is best in performance and why? And what is worst in performance and why? Even though it's worst in performance, why people picks that? So these kind of questions you may get in interviews. Now let's discuss each and every one. So what is the advantages of MOLAP and disadvantages of MOLAP? So MOLAP is the best one in performance. Super good. The fast, it says at least 10 times faster than ROLAP. relational queries, minimum 10 times faster. The performance is good. That's the advantage of MOLAP. Okay. Now let's see what is rollup advantage. The data will be in rollup and aggregations will be in relational database. Here data will be in multidimensional and also aggregations, right? So when you query, it's already polished data, so it will immediately fetch the data. The performance will be super good if you point to rollup. Okay. If you write an MDX query and if it is rollup storage mode, again it will convert it into SQL Server. It will get the data from rollup. It's nothing but writing a simple select statement or SQL statement. We are going for SSAS cube just to improve the performance. Why? Because the select statement is taking time. Now it will be the same story again, but only advantage is some aggregations will be created here. So the disadvantage of relational is slow. This is super fast. MOLAP, this is super slow. And hybrid, when you are getting high level data, that is aggregated data, then it is super fast. When you are getting low leaf level data, that means the pure leaf level data, then it is super slow. Why? Because aggregations will be stored in analysis server, whereas data will be stored in relational database for whole app. So this is the performance wise, the speed wise. Now this is super slow, but why people prefer this? Why? Because this is real time. Real time in the sense, if I add one fact record into this, and if I query in my browser, or if I query using MDX query, I'll get the data. The record I added at any point of time, I'll get it. Okay. But this is, if I query the data here, let's say I process the cube today, and I'm querying the data tomorrow. And between the time I process the cube and the time I'm querying the data, let's say 1000 records inserted, I won't get that 1000 records if it is MOLAP. Why? Because let's say this is my project. If I process it, it will fetch the data and place it here. And again, to get the fresh data, I have to process again. So in other words, the MOLAP storage mode is always outdated one. Always outdated one. If I process this second, next second it will be outdated one. In short, if I say MOLAP storage mode, if I process a cube today, and after 2000 years, if any guy comes and access the cube, he will have the same data what was there when I processed the cube. So it's always outdated. But this is not like the rollup. This is real time. Okay. And in short, MOLAP, it is super fast. Rollup, it is super slow. And whole it is fast if it is high level data, but slow if it is low level data, leaf level data. And MOLAP, it's not real time, it is always outdated. Rollup, it's always real time. And whole app, it is real time for leaf level data, but not real time for high level aggregated data. Why? Because aggregations will be created only when I process the cube, even it is for whole app. So this is the advantages and disadvantages, and why people prefer rollup means just because if the requirement is to get real time data, fresh data always, then they'll go for rollup. When the data is less and they want to see fresh data always, then rollup is the option. When the data is huge and performance is the important for the users, then they'll go for MOLAP, and I don't see any option where people use whole-app. So as the data is not physically moved from relational to analysis services in the case of rollup as well as whole-app, what will be the advantage? The processing time will be very less. Generally the processing time, the time taking part is whole-app. Sorry, the time taking part is copying the data, moving the data from relational to analysis server. You don't need to do that. That part is not useful, not available for whole-app and rollup, and hence the processing of the cube, when you click on process, it will be very fast. Let's say I have 500 crores of data, and if I set that to rollup, it will just create aggregations. So how much time it is going to take? It will take very less time compared to MOLAP. Why? Because it has to do two things. One is moving the data, and second thing is creating aggregations on the data. So moving the data is very, very time taking task. It has to read all the records and it has to push it into the analysis server. So the processing time, the rollup will be fast, but the querying time, the molap will be fast. So now this is about holap and molap and rollup. The only disadvantage I can see for molap is not real time. It is not real time. That is the biggest disadvantage. Processing, you can overcome it. You can tune it, or you can do one thing. You can do incremental processing, and that means only the changes can be fetched. Or you can do nightly processing. Night 12 o'clock, if you trigger by morning, it will be completed. So you can avoid. You can find some workaround for that. But the problem is real-time data. No way of getting real-time data into the molap. But there is a way to get a pseudo real-time. Not exactly real-time, but pseudo real-time. There is a way to get always a fresh data into your molap cube. If I can get that, then molap is the awesome option, right? And rollup is of no use if I can get the real-time data into my molap storage mode. So there is one option. And this is the assignment for you guys for today, and I want you to prepare a document on, you have to find out what is that option. I'm not going to tell you that, and prepare a document on the same and submit it by tomorrow, before tomorrow's session. So that's the assignment for today's session, and that's it for today's session, and I'll catch you in tomorrow's session. Thank you. Have a nice day.